State one disadvantage of using quota sampling compared with simple random sampling. Well, simple random sampling, as the name suggests, is random, whilst quota is a non-random method. Essentially, it's a type of convenience or opportunity sample, but you're just trying to fit a certain quota. Maybe you're trying to get certain percentage of different age ranges or something like that. It's the non-random version of stratified, and that just means it's unreliable. So I just wrote high chance of bias. Now we're told in a university, 8% of students are members of the university dance club, and a random sample of 36 students is taken from the university. X represents the number of these students who are members of the dance club. Using a suitable model for X, find these probabilities. So we have a fixed number of trials here. We are asking 36 people whether they're in the dance club or not, and they either are or they aren't. So this is going to be a binomial distribution. 36, the probability of success of being in the dance club is going to be 0.08. We are assuming a fixed probability. We are assuming that events are independent when we pick people. So if we want the probability that x equals 4, all right, we can just put all of this in our calculator now. Distribution, it's binomial PD. Variable just does one value, and then 4, 36, and 0.08. This gives 0.16738, which we're going to round to 0.167. I always like to just remind people what your calculator is actually doing to get this. Really important to understand it. So essentially we have 4 successes and 32 failures. So if I went down one branch of the tree diagram where I had 4 successes in a row, it would be 0.08 to the 4. And then if I then had my 32 failures, it would be 0.92 to the 32. But now I've got to take into account the fact that I could maybe get 3 successes in a row, then a failure, and then a success. I could arrange these in many different ways to get the 4 successes. So this is where the idea of arrangements comes in. And we're arranging 36 objects, so 36 factorial. However, 4 of them are the same. So every time I swap them around, I'm actually kind of not quadruple counting, even like counting it lots and lots of times. If I swap these two around, it's the same thing, for example. So I divide by 4 factorial because that's the number of ways that we could arrange those 4 S's for any given arrangement. And then I divide by 32 factorial. This is also known as 36C4. And if you put that into your calculator, you will get exactly the same answer. Then for a probability that x is greater or equal to 7, I'm going to use the cumulative function of my calculator, which only does less than or equal to. So it's going to be 1 minus the probability that x is less than or equal to 6. Because I want 7 and beyond, so I'm taking the entire certain probability of 1 and I'm minusing 0 to 6. That will leave me with 7 to 36. So we use a slightly different function now. Back to distribution, and it's the binomial CD. Okay, calculator stores some of this really helpfully. So we've just got to change that to a 6, and it's going to be 1 minus 0.977 and so on. Which then gives 0.022233 or 0.0222. Now we're told only 40% of the university dance club members can dance the tango. Find the probability that a student is a member of the university dance club and can dance the tango. So for this, we're going to take the probability of them being in the dance club, 0.08, and then it's 40% of those that are in that can dance the tango, I'm going to times through by 0.4. And therefore we get 0.032. And finally, a random sample of 50 students is taken from the university. Find the probability that fewer than 3 of these students are members of the university dance club and can dance the tango. So I've got a new binomial distribution to consider here. We're looking at 50 students, and the probability of any single one of them being part of the dance club and being able to dance the tango is that 0.032 I found a minute ago. I want the probability that fewer than 3 of them can are members of the dance club and can dance the tango. So that is going to be x is less than 3, sorry, y is less than 3, or we want to change it to less than or equal to, so y is less than or equal to 2. Okay, and that's the hard work done. I just need to put that on my calculator. So back to this, it's still a CD. Now it's going to be 2, 50, and 0.032. We get 0.7850. So there's a very high chance of fewer than 3 being in the dance club and being able to dance the tango. 0.785, so 3 significant figures.